Hello students, and welcome to another video. In this video we're going to discuss z-scores. First, we're going to learn how to compute the z-scores. Why do we use the z-scores to begin with? The z-scores tell us exactly how many standard deviation from the mean a data value is when the histogram is bell-shaped, also called a normal curve. So when we are dealing with a normally distributed data, we will be able to use the z-scores to determine how far is a data value from the mean in terms of standard deviations. We need the z-scores to usually compare two values from two different sets of data relative to their mean. For example, if you want to compare the height of a woman to a height of a man, then you will need to find the z-score for the woman relative to the average height of women, and then find the z-score for a man relative to the average height of men, and then you're going to compare the z-scores instead of comparing the heights head to head. Because it's not fair, we know that on average men are taller than women, and a short man could be taller than a woman in inches. However, he could be relatively shorter than a woman if compared to the average, or if compared relative to the average of each group. We will look at how we're going to compute the z-scores. The first step in comparing the z-scores is to use this formula. To compute the z-score on Excel, you're going to use the function standardize. And that function is going to ask you for the value that you need to standardize, which is the value that you need to find the z-score of, and it's going to ask you about the mean, and it's going to ask you about the standard deviation, and you're going to separate them with commas. If you want to use a formula to compute the z-score, this is going to be the formula. You're going to take the value subtracted from the mean and divide by the standard deviation. Let's see here if we can compute z-scores for given values. Using a mean of 100 and a standard deviation of 15, calculate the z-score for the following x values. So the first value that we have is x. X is equal to 92. The second value we have is the mean, mu. Mu is equal to 100. And the standard deviation, sigma, is equal to 15. The z-score for 92 is going to be 92 minus the mean, I'm using this formula, divided by the standard deviation, which is 15. Now the answer is going to be negative 0.53. This tells me that 92 is exactly 0.53. It's not exactly, this is rounded. It is about 0.53 standard deviations below the mean. Why I said below? Because of the negative value here. So the z-scores can be negative and can be positive. So 92 is 0.53 standard deviations below the mean or the average. Now if I want to compute the z-score for the other value, which is 124. 124, we have x, we have the mean, which is 100, and we have the same standard deviation, which is 15. The z-score for 124 is equal to 124 minus 100 divided by 15, which is going to give me, it's going to be 1.6. It's going to be 1.6, which means this value, the 124 is 1.6 standard deviations above the mean. Now I'm going to show you how to use the function standardize to compute the z-scores. So the first one is when x is equal to 92, and we have the mean. Let me actually write x here and write the value 92 here, and then the mean is equal to 100. And then the standard deviation is equal to 15. And then I will do it for the other value of x, which is, I'm going to stick it in here. So the other x, let me say this is x2, is 124. All right, so I'm going to say Z1 for X1, this is X1, is equal to standardize. I'm going to click on the function standardize. It's asking about X, so I'm going to click on the value for X, comma. It's asking about the mean. I'm going to go click on the mean and then comma. I'm going to click on the standard deviation and then enter. As you see here, it's negative 0.53. If you round it to 2 decimals, it's going to be negative 0.53. I usually round the z-scores to 4 decimal places. Z2 is equal to, again, standardize the value 124, comma, the mean is 100 and the standard deviation is 15. So that value is 1.6. It is the number that we got, so we don't need to round it, but usually we round the z-scores to 4 decimal places. Here is the one used for the z-scores, which is comparing two scores that belong to different exams. Carson took the SAT and scored a 1,325. Taylor took the ACTs and scored a 29. The mean of the SAT exam is 1,060 with a standard deviation of 195, while the mean for the ACT exam is 21 with a standard deviation of 5.4. Who did better on their college entrance exam? To compare those two, we notice how the SAT is different from the ACT, so we cannot compare these scores head to head. So we need to measure how far each of the scores from the average of the test. To measure that distance, we're going to use the z-score. So I'm going to do the math here. I'm going to say the z-score for Carson, or for the SAT for Carson, is equal to X minus the mean divided by the standard deviation. We know that X for Carson is 1325. We know that the mean for Carson, or for the SAT, is 1060, and we know that the standard deviation for Carson is 195. So I'm going to compute the z-score for Carson. You can plug in the numbers, but I'm going to use Excel, and I'll be right back once I compute it. I computed that, and it was equal to 1.3590. 1.3590, rounded to 4 decimals. I will do the same for Taylor. So the z-score for Taylor is basically X minus the mean divided by the standard deviation. I know that X, the score for Taylor, was 29, and the mean for the ACT, which is Taylor's exam, is 21, and the standard deviation is 5.4 for Taylor. So now I'm going to compute the z-score for Taylor on Excel, and I'll be right back. The z-score was 1.4915. Notice how Taylor's z-score is higher than Carson's z-score, which means compared to the same point, which is the average for each, Taylor is here, that is Taylor, and Carson is here. We're comparing to the same point, which is the average for both of these exams. So now we can tell definitely that Taylor scored better on the ACT compared to the SAT score for Carson, because her score is almost 1.5 standard deviations above the average, while Carson's score is only 1.4 standard deviations above the average. So I hope that clarified how we're going to use the z-scores. And let's go to a different example here. Let's say we are given the z value, or the z-score, and we want to find the corresponding x value. So to compute the corresponding x value that corresponds to a certain z value given the mean and the standard deviation, we're going to use this formula right here. You will take the z-score multiplied by the standard deviation, and then you're going to add the mean. So that is the formula. There isn't a formula on Excel to compute this directly, so you have to apply this formula. Let's look at this example. Lucas knows that his height is 2.4 standard deviations above the mean for his age and gender. The mean height for his age and gender is 68 inches, while the standard deviation is 3 inches. So let's jot down what we have. We have the z-score for Lucas, which is 2.4 standard deviations. Of course, it's positive, so it's above the mean. And we know that the average height for his age and gender is 68 inches, and the standard deviation is 3 inches. We need to compute his height, which is the x value in this case. Now, the x value is equal to the z-score times the standard deviations plus the mean, which means his height is equal to 2.4 times 3 plus 68. Now, I'm going to compute that on Excel. You can do that on any calculator, but I'm going to do it on Excel here. Equals 2.4, was it 2.4? Yeah, times 3 plus 60. So I just did the calculation immediately, and the answer is 75.2. So this is 75.2, and the height is measured in inches because the average was given in inches. So I know that the height of Lucas is 72.2 inches. Very important to include the units here. Let's look at another example. You're trying to get into college, so you decide to take an Accuplacer exam. You currently have a GPA of 3.2, and you wonder what score on the Accuplacer you would need to be equivalent to that. You do some research and find that the mean Accuplacer score is 40 with a standard deviation of 8. You also find that the mean GPA is 2.8 with a standard deviation of 0.3. So the first step that you're going to do is to compute your z-score for your GPA. So we're going to compute the z-score for your GPA. We know that your GPA is equal to 3.2, and we know that the mean for the GPA is equal to 2.8, and the standard deviation for the GPA is 0.3. So the z-score will be equal to 3.2 minus 2.8 divided by 0.3, which is about 1.33. Now that we turned your GPA into a z-score, we can find the equivalent Accuplacer grade. So the equivalent Accuplacer is equal to your z-score GPA of the GPA times the standard deviation of the Accuplacer plus the mean for the Accuplacer. We know that the mean for the Accuplacer is 40, and we know that the standard deviation for the Accuplacer is 8. So now your score converted, or your GPA converted to an Accuplacer, is going to be 1.33 times 8 plus 40, which is going to be roughly, to summarize, first we're going to compute your z-score, turn your GPA into z-score, standardize it. We know that the GPA is 3.2 and the average GPA is 2.8, and the standard deviation for the GPA is 0.3. We're going to use these numbers in the formula to convert your GPA into a z-score. Next, we're going to take your z-score and turn it into an Accuplacer by using the average for the Accuplacer, which is 40, and the standard deviation of the Accuplacer, which is 8. And then we use this formula to compute your grade, or the equivalent of the GPA in Accuplacer. and we get this sense. I hope this video helped you understand how to use the z-scores. We will be using them next week as well, so make sure that you understand how to use them. Thank you so much for watching, and if you have any questions, let me know.